Hello again, everyone. Well, it sort of had to happen again, given the size of my body and the number of parts that I've got to fit into me. Charles had built my chest, as you can see here, but some of my parts were too big by a couple of millimeters. Using the same chest artwork, Charles forced some more space out of the design before reprinting it. So, here we go again. Before we go any further, let's ensure all my parts fit loosely as they should. And my rib cage can slip over without catching on anything. In case you are wondering, my rib cage is a Buffo 5-4, a lid for holding my parts inside me, with a little bit of aesthetics thrown in as well. Great. Now my power controller board fits correctly, we can get on with my build again. Charles will strip all of my components off my old inner chest assembly off camera. Then we can start my assembly process again. Oh, the pleasure of prototyping. I'm sure I'm giving him a lot of grey hair. Now all my parts are spread across the workspace. We will sort things into the installation groups. First part to go in is my abdomen servo. This is not screwed into place until all of my wires are run down my chest. I have data wires threaded down the front of my chest. Later on in my build, Charles will run my leg power wiring and USB cable down the inside of my back. My chest IMU wiring now goes down my chest to where my pelvis pico will be. Now we screw my chest IMU down onto the front carrier. Hopefully it will be far enough away from the servos so the magnetometer on it will work correctly. We now have my data power switch being locked into place. I have two power switches, one for my data and the other for my servo power. Next, my power LED is put into place. This is a 3-color LED that tells Charles when the power switches are turned on and also when my brain says I have powered my servo power circuit up safely. When this is done, my servo power switch can be locked down also. Next, my chest USB hub gets wired in place above my abz servo. As you can see, even here the spaces inside me are very tight. Charles could have made me larger so things would fit easier. But he wanted me to maintain my childlike proportions as I am already on the limits for many of my servos. More wiring, this time for my pelvis pico to be able to communicate to my chest servo 2040 board. My USB hub is clipped into its carrier. I have a USB connection to all my Pico ports for communication as well as in-place programming. Now my servo battery is slicked into place to lock my data wires and USB hub down. Now for the making of my power distribution board. This is the part that caused Charles so many problems. Its main job is that of a mid-body termination point as well as the place my batteries connect to the rest of my circuitry. Talking about my batteries, I have two 64 watt-hour lithium iron phosphate packs, one for my data and the other for my servos. There are two connections off each battery pack that are used by me, the USB-C for charging and the USB-B for my power data or servo supply. I also have a field effect transistor on my board that switches the power to my servos on and off dependent on what I am doing. This was put in so that I could read all my IMU data on power up and work out approximately what position I am in before starting my servos. This hopefully will stop me from flailing my arms and legs around when I wake up, as that won't be a pretty sight at all. Before we go on too much further, my shoulders and head assemblies should now get attached to my chest. This entails feeding my head and arm wiring cords down through the hole in the top of my chest. You will notice there are a lot of wires coming down through my bus assembly. All of my upper body servo wires, my power feed wires, as well as my communication lines. All of these need to be fed through to their appropriate board spaces in my chest.
It is when these wires are fed and that things get really tight.
Once my shoulder and head wiring is in place, we can slip my chest onto my bus assembly. This sounds easy, but it is not. Charles made this joint extra tight so I won't wobble about on the axis. With my longer upper chest to bus carriers, I have a lot of room to move in my X and Y axis. Charles will need to be sure that there is no chance of me overbalancing when he does my full body programming.
This is why I have so many IMUs inside of me.
It is to help ensure I have a good posture when I stand and move around. Once we are certain my joint lines up, we can put the servo horn in place and screw it down. That is one of the neat things about my design. I have several 1-screw separation locations for maintenance. You can see as Charles is flexing my bus assembly joints to feed my wires through, just how flexible I am on the X and Y axis. We can put my servo battery in place now before we move on to wiring my boards up. Let's start with my chest servo 2040 board. This controls my head, shoulder, bust and arm servos as well as absed servo. Using 2 of these boards in my body keeps all my servo wiring all within 2 manageable areas. This is going to be useful later on during the programming stage of my build. It is just a matter of plugging the cables into the correct ports, then gently slip the board into location and run the USB wire down my back to the hard. You may have noticed a few wires just being wrapped around the cables. These are spares for future expansion if required. Now for my main power distribution board. This needs to be wired up to the remaining plugs. But first, we need to shorten my battery USB cables so they will fit inside my ribs without snagging. It's a balancing act of length being too short or too long. So you will see the cable is about 25% longer than the direct run.
This gives wriggle room if needed. This needs to be done for both batteries' USB cables.
My USB-C cables plug into my battery first and my USB-A plugs in over top of it to keep the profile down.
The adapters on the end of my power board are from USB power packs.
Their only job is to tell the logic in the battery packs that the voltage coming in to charge the packs is 5 volts.
That voltage will come from my induction loops in my feet later on.
You might have seen the red LED lit, but not the green.
So we have a little problem to sort before we continue.
Who would have thought such simple wiring can be this problematic?
Well, it ended up being a strange one.
The load of the LED was not high enough for my battery pack to detect a load and supply power.
Lots of connectors to go into their respective sockets and at the same time keep a low physical profile.
This is all the cables in place except for one that still needs to be made.
This cable is the I2C cable from my data battery current sensor to my pelvis pico board.
You may recall my chest IMU goes to the I2C port of my pelvis pico, so Charles will run a cable from my IMU to keep the long wire count down. Once this cable is soldered up to both boards, then my power supply can be slotted into position. We can run my cables down the inside of my back down to my ADZ carrier location, so it's ready for testing. Well, it has been a marathon getting this far with all the little issues that have cropped up. But now we know about them and have them recorded for anyone who wants to follow. We will leave my ads and testing until the next video, as this one is already getting quite long. So until then, happy robot building!